Right, this video is for lesson 10.0a. We're going to talk about reducing square roots. So today we'll be looking at simplifying square roots. And when we do that, we mean we don't want any decimals. We just want to break that square root apart. So first, we'll get into some easy ones where it's a perfect square already, and then we'll build into the ones where we have to simplify. First off, a radical. The radical is just this. Okay, it's the name of the symbol that means square root. So a radical is just a square root. Square root symbol is called a radical. So everything this chapter is going to be a radical expression. So it's going to be expressions that involve that square root symbol somehow, some way. So we're looking at no variables today, just numbers under the square root, under the radical sign, and just trying to break those down as much as we can. So if it's already a perfect square, okay, then they just have an answer. So the square root of 4 is just 2. These are ones that you can just put in your calculator if you're not sure. Square root of 4 is 2, square root of 81 is 9, square root of 36 is 6, square root of 121 is 11. So if it's already a perfect square, you can get rid of the radical by taking the square root, by evaluating the square root. These ones have fractions involved with them, and they work kind of like you would hope. So it's what this is a perfect square over a perfect square. So what we can do is we can take the square root of 9 and the square root of 100, which is 3 over 10. This one is the square root of 25 over the square root of 49. So we get 5 over 7. And so what we can do is just split this square root up. If it's the square root of a fraction, you can take just the numerator and just the denominator and treat them separately. So this one is square root of 64, so 8. Square root of 81 is 9. And then same thing with 1 over 16. We can write that as square root of 1 over square root of 16, which is 1 over 4. So if it's already a perfect square, we just say what that answer is, whether it's a fraction or not. Then you get into the ones that are not perfect squares. This is what I want to spend more time on today. So if it's not a perfect square radical, okay, this is going to be kind of the key to how we want to do that, okay? And what it's saying is if you have a product, if you have a multiplication sign under the square root, you can split it up into 2 separate square roots. So, and that's what we'll practice doing. In order to do this today, we're going to want to know some perfect squares. So here's a list of the first 15 perfect squares. If it's too fast, I would pause the video and make sure that you have it written down. But these are all numbers that are going to help us today because we might be pulling out certain numbers from the square roots that we're about to see. So there's more perfect squares than that, but that's just the first 15 perfect squares. Okay, so what we want to do, okay, in order to do this, okay, the square root of 24 is a decimal. If you punch that in, it's 4.899. Okay, we're not doing that this chapter. We don't want decimals. There's not going to be decimals anywhere this chapter at all. What we want to do instead is we want to break that square root up. And what we do is we find the greatest perfect square that goes into that radical. So 24, since it's a decimal, we would break it down with a perfect square. So we'd look at that red list and see if any of those numbers go into 24. And they do, so I'm going to start over. 24, we can write that as, we want to write it as a product with a perfect square. So 4 is a perfect square that goes into 24 6 times. And then what we can do comes back to this part here. If you can write it as a product, you can split that perfect square, or that square root up. So I can write this as 2 square roots, 4 and 6. And then the square root of 4 is just 2. So I can get this down to 2 times the square root of 6. So that, if you punch that in your calculator, it's 4.899. But this is the type of answer that we'll be looking for this chapter. 20, you can take the same thing out. So for square root of 20, we would write that as square root of 4 times 5. 4 is a perfect square that goes into 25 times. And then we can split it up. That's the square root of 4 times the square root of 5 separately. And we know the square root of 4 is 2. So the simplified version of square root of 20 is 2 with a square root of 5 after it. Okay, and we'll just keep trying some examples. So it's not always a 4 that we pull out. So this one, 63, what you would take out of that is a 9. This is the square root of 9 times 7. 9 times 7 is 63. Okay, then we split the square root. The whole point is that we have a perfect square and a non-perfect square. The square root of 9 is 3, square root of 7, and then it's fully simplified there as long as we have the biggest perfect square. So none of these so far, okay, this one, this one, this one, if you look at those ones, none of those have a perfect square factor. So I know that I can't break up a square root of 6 anymore than what I already have. So same with square root of 7, same with square root of 5. So if you want to know if you're done, you look at the number that's under the square root. If it is still something that you can break down with one of the numbers in the list, it just means that you could have taken something bigger out and that you're not done. So let's move on to square root of 90. So square root of 90, we can write as square root of 9 times 10. 9 times 10 is 90. And then the square root of 9 is 3. So I can pull that square root of 9 out front and turn it into a 3 with a square root of 10 after. Okay, square root of 27 is another one where we would take out a 9. This is the square root of 9 times 3, which is the square root of 9 times the square root of 3, which is 3 square root of 3. And the beginning of your Delta Math assignment looks a lot like that, where you're typing it in kind of step by step. Last one on this page is 50. So the biggest number in the list that's going to go into 50 is 25. We can do 25 times 2. So that's the square root of 25 times the square root of 2, which is 5 square root of 2. So again, just to remind you what we're doing, if you type 5 square root of 2 in and square root of 50 in, you get the exact same decimal both times. All right, so that's the first few examples. We'll move on and try a few more. If the numbers get a little bigger, and then if there's numbers out front, not too much needs to change. Okay, 175. Okay, it might take a little bit of trial and error, but something that ends in 5 like that, sometimes those are multiples of 25. So if you take 175 divided by 25, you get 7. So I would use 25 and 7 for this one. 25 times 7 is 175. So we can write this as square root of 25 times square root of 7. And then we can write it as 5 times the square root of 7. 245 is one, again, when the numbers get a little bit bigger, trying to find something that would work in the list for that. So when you're looking at square root of 245, that one, 25 is not going to work. But what we can do is anything that ends in 5, you can divide by 5. So if you do that, if you do 245 divided by 5, that's 49. And 49 is in your list. That's a perfect square. So we want to write this one as 49 times 5 so that we can pull out a square root of 49 out front, which is 7. 7 square root of 5. And then we continue with the same types of problems. So I'll do the two on the left here before the two on the right, just because the two on the right have something different about them. 150 is another one that you could take 25 out of. So you could go square root of 25. 25 goes into 150 6 times. So we can write it as square root of 25 times square root of 6, which is 5 square root of 6. And then, like I said, before we do the ones with the number out front, let's look at square root of 72. I'll come back to it. So there's a few options for 72. So let's talk about that. This is a good one to look at, because the perfect square of 4 goes into 72 18 times. But there's stuff that's actually, there's perfect squares in the list that are bigger than that. So that's not the one that we want. We could do 9, because 9 goes into it 8 times, but there's something even bigger that would work. Okay. And it would be 36. 36 goes into the 72 twice. We're going to pick this one. Okay. Just a reminder, you want the largest perfect square. So some of these numbers have more than one perfect square that would work. You want to pick the one that's the largest. So we want to pick square root of 36 times 2. So that's square root of 36 times square root of 2, which is 6 square root of 2. So you always want to try to find the biggest one. If you do 4 and 18 or 9 and 8, you would just have more than one step that would have to get done. So the last thing to talk about for the video is if there is a number out front, so just what to do with it. Okay, if there's a number out front like this 2, just leave it until the very end, and then we'll multiply it in, and I'll show you where. So for now, we're just going to keep the 2 as a part of it, and then we're going to try to take a perfect square out of 300. And the perfect square we can take is 100. We can take 100 out of 300 3 times. That's the biggest perfect square that goes into 300. Then we can write it like this: 2 times square root of 100 times square root of 3. And then what we get with that is we can turn the 100 into a 10. What we can do at that point is we can multiply the 2 and the 10, because they're both outside of a square root. So that would give us 20 with a square root of 3 after. And we can do that one more time. It's a negative 2 out front this time. That's going to be our last step. We're going to divide whatever we pull out by negative 2. The biggest perfect square that goes into 216 would be 36. It's going to go in there 6 times. So we can write this as negative 2 times square root of 36 times square root of 6, which is negative 2 times 6 times square root of 6. And then we can multiply these two numbers and write it as negative 12 square root of 6. And that would be our answer. If you want to make sure you're right, you can always type in your last answer in the calculator, get the decimal for it, and type in the first thing that you had and see if it's the same thing. But that's it for 10-0A. There's a Delta Math to practice. Thanks for watching. Have a good day.